Mhm. So in this video, I'm going to tell you about time complexity and space complexity. Like time complexity is what? Like what exactly time complexity is, and it's a quite an important term when it comes to the context of what we write a code. What we know is that optimization. Now, what do exactly does this word mean? Optimization. Now, optimization is like that. The machine that runs the code actually requires some time. As a programmer, it's our duty to optimize the code, like to make the code of an appropriate length that it gets run in a small amount of time or considerate amount of time. People who do coding on the platforms like CodeChef and all, Lead Code and all, they prefer it to get the code optimized. Now, basically, what we do in context of optimization is that we try to write the code of length or basically using the factors that to keep in mind, which we normally take into account, like the loop. Like if we write the for loop, so or any kind of other loop like for, do, while, or while loop, especially for and while, first of all. So for loop takes like the number of operations that it will do. Now, for output, if we write a condition from I is equal to 1 and we take it to I less than equal to n. This is our condition that, and it is getting incremented. It is getting incremented plus plus times. This is our basic syntax of for. Let me erase this. So this is I. Now, basically what our syntax here is for loop. For I is equal to 1, I less than equal to n, I plus plus. Now, more often than not, when we encounter such problems, like first of all, let me tell you for how long this code will run. So this starts from the value n, and this runs till the time is equal or less than equal to n, and it gets incremented every time by 1. So this n will be a value that will be entered by the user. It's an arbitrary value at the moment. So like it's an arbitrary value at the moment. So like for how long this code will run. So the for loop actually when it is incremented by 1 and it runs till n, and it has been initialized by 1 as well. It runs till the time n plus 1, n plus 1 times. Now, like there will be a question that I wrote the syntax here for loop that was running till n, and it was always incremented by 1 every time. So, like how exactly it came n plus 1. So, this 1 comes from the fact that the loop will also be checked. Remember what I'm saying. The loop will be checked when it is also terminating. Like if it is not fulfilling the condition, suppose like our n was equal to 4 and the value of I after incrementation has become 5. So even though now I less than equal to n does not hold true, like this condition does not hold true, but still this condition will go here, and in total this will become n plus 1 times. So in total it becomes n plus 1 times it. Now, what will be the time complexity of that? Now, time complexity of a for loop, when it encounters a fact like it is being initialized from 1, it is being with a condition is still n. and it is being incremented by plus one every time. So like till what will be its time complexity? So as we know that time complexity we will express in terms of big O notation, like big O notation I have already taken in my video. Big O, big O notation. So like in this notation, what will be its time complexity? So in time complexity, we care about the degree of, remember that this is very important, the degree of n, degree, degree of n, or to be more precise, I will write here degree of polynomial n. Now, we are doing here degree of polynomial n. Now, why I wrote this? Now, the last time, like, let me tell you. Now, the for loop that I wrote, I will write the for loop here once again in order to avoid the confusion. For, I think, just excuse me for if it is not that. For I is equal to 1, I less than equal to n, I plus this. So in that case, this loop will run till n plus 1 times. Now, what I wrote here by big O notation, the degree of polynomial n we are considered, we will be writing here. So now, though it will be, and it will run for n plus 1 times. So if we write here, the time complexity will be O n plus 1. Now, this is exactly wrong because we were concerned with degree of the polynomial. That is, we are considered with the, and degree is what? The highest power term. Simply, this is the thing. The degree is the highest power term, isn't it? So, like that, we will come here and we will build writing here. O, in this case, it is O and simply. It is O and. In this case, this is O n, time complexity. This will be your time complexity. Now, if we consider here space complexity, I will also tell. Now, what is exactly space complexity? Now, whenever you initialize an array or any kind of a variable, they take a certain space in the memory. Now, when they take certain space in the memory, now depending upon the number of variables and the number of arrays that you have actually initialized in your program, a particular space will be taken. So when linear space, now ideally we are supposed to take it in linear space, like single linear space, then we take it O of n, the spaces. Now, the other thing is that when we take constant spacing, now constant spacing is O of 1. What is it? It is O of 1. So like that, space complexity is there. Now, suppose if I'm initializing int, if throughout a program I just initialize one variable in a program, that is int s is equal to 0, 1, 2, 3, or something of that kind, I just initialize. So I will be simply doing here what? This will be taking the space O of 1. Now, O of 1 is what? This is constant spacing. This is what? This is constant spacing. Now, moving on, let me tell you some more things. I will be writing a segment of code here, and through that I will be explaining here what is exactly I want to tell, and I will just completely, I will again just using that same example, this, and here I have taken some statements. These statements can be anything. This can be if you are doing your programming in C++, then this can be C out any kind of this variable itself. Or if you are doing in Java, then it will be system.out.println. Any kind of mathematical operation can also be here. So, and this gets you to the end of. Now, what I have done is here after now is that I've explained you the basic for syntax, which will take ON, time complexity. Now, what I will do here is that simply I will be explaining you the concept of while as well through one more video. I will be there and I will be explaining you the concept of while through that. So what I will be doing here is that, see, I will be doing here is that, as I told you, this for will run for how many times? This will run for n plus 1 times. This statement will run for single time. They will run one time each. So their time complexity becomes O of 1. Their complexity becomes O of n. And in total, the time complexity of this is O of big O of n. This will be. Now suppose if I tell you another thing, let me just erase this first. Supposedly, if I erase this as well, and I hope it's clear. Supposedly, I write here I plus equal to 20. This is 20. Okay. Now, supposedly, if I write I plus is equal to 20. So, how do we exactly do this? So, in the number of times this for loop will execute will be now not, it will not be n plus 1, but it will be n plus 20. So, our time complexity now is not O of n, but it will become O n by 20. But we don't exactly write n by 20. I will tell you. We don't write exactly O n by 20. We simply write still O of. Now, the initial definition of time big O notation, what I told you was like that we don't focus on the expression, we focus on the degree of the polynomial. And degree of the polynomial we always get from the, like if it is here n by 20, or sorry, if it is n by 20, so it's still the degree of the polynomial, that is the term with the highest power remains n. So we simply write here n. Now, the next thing comes here. If I go about that, the next thing moving on, now I will tell you this was about increment, and the same goes for decrement as well. Now, increment and decrement are the linear operations that will happen like progressively. When it comes to the factor of multiplication and division, I will tell you how to analyze that. So when it comes on the fact for I is equal to 0, I less than equal to n, okay, take it 1. Take it is as 1, okay, and I equal to I into 2. Very common fact. We are writing some statements here, and then this loop is clear. Now, to analyze the time complexity of this type of things, when the factor is given, when it is not incrementing, but it is actually the control variable or variable I is updating in the form of product. It is being multiplied by a factor. So how to take out the time complexity of such cases? Now I will tell you that you can't simply do it of the fact that this will come into, if you write it that this loop will run for n plus 2 or n into 2 times, then this is totally wrong. Okay. It won't run n into 2 times. Now, how it you can't now when it comes barring the fact that when it is being updated by plus operator or like postfix, prefix, multiplicator operators, like if it is happening postfix like plus plus or minus minus when it is happening, only then you can simply say that it is being running for like n plus one times or kind of that concept. Blindly you can't tell like in these cases. So how you will judge? You will actually try to analyze it. Now how you will analyze? You will write the value of I and you just simply do it. Now initially and the value of updated value, also the condition. Initially I will be 1, then I becomes I into 2. The updation is there. So initially I becomes 2, then I becomes 4, then I becomes 8, then it becomes 16. So there will be a time when I will become something called as 2 to the power k. It will reach. Now, k is what? This is a variable. This is the after a certain stage we are analyzing it. So we are supposedly the program has run for k times. And at that particular time, the value of I will be 2 to the power k. Now, based upon our analysis, if we see I is less than equal to n, now, this condition, this loop will be running. The condition will remain true till the time the value of I is less than equal to n. So when we have to analyze it simply, how we will be analyzing it? Now, after care time, we are seeing, like, see, let me write here. After k times, after k times, the value of I. Now, this is the value of I. Now, if we need to analyze the time complexity, how will we analyze it? We will be analyzing like that. When the value of I becomes greater than n, this loop will fail. So now 2 to the power n is greater than equal to n. It will happen something kind of so 2 to the power n is greater than equal to n. Now when we take log of this, like this will come log 2, this will come log n, and this will come here a. So eventually we will be realizing here that k becomes k greater than log n base 2. So in those cases, our time complexity becomes Tc becomes big O of log 2 base n. And if I write here, so it's not a general thumb rule. This too comes from the fact, let me tell you. This too simply comes from the fact here we were multiplying it, that we were updating the value of I every time by 2. Supposedly, if you are being asked by 3, then finally it will come big O of log n base 3. Whatever is being multiplied to the variable I or any kind of a control variable in the loop, the base will come here. And if I go about dividing, if I go, suppose that the variable is being updated by every time dividing it by 2. Supposedly, this 2 can be changed to 3 as well. Finally, the result will come. the change will be happening. I'm telling you again. So here I'm taking you to the fact of divide for int, or it can like you can take double also. We are not focusing here on writing the code with proper data types. We are focusing on here to how to take out the time complexity. So for I is equal to 1, I less than equal to n. This n is an arbitrary value like we normally been have been doing the programming in which we are have to take a particular range. So this n value is that. So I presume that you know this. So this is the syntax. Oh, sorry, I wrote plus. I have to divide it. Okay. So I have to divide it. So I is equal to I by 2. Okay. So this is I is equal to I by 2. Now, in that case, again, I will be writing here some statements. These statements will always be having their complexity as big O of 1 and like that. So now in this question, compared to the last type of example that I told you, in that the value of I was being multiplied by 2, and in this question, the value of I is being like divided by 2 every time. So just like the previous type of example or scenario, we in this case also we can't simply say that it will the loop will run for O n plus 1 times big O of n plus 1 times, and we simply say the time complexity is big O of n. That kind of concept is completely wrong. So for the particular type, when the updation is being done in the type of like multiplied or divide, we can't simply say that it will run for big O of n times. So we have to analyze it. So just like the previous kind of concept, I will be updating the value, or I will be analyzing the value. So here is the value of I, and initially the value of I given in our for loop is 1. So the value of I here is given as 1. So how we will be doing this? So initially the value is 1, then the value is being updated as 1 by 2, then it will become 1 upon 2 square, then it will become 1 upon 2 to the power 3, and after k times, the value will become, and after k times, the value will be, so after k times, this, the value of I becomes I is equal to 1 upon 2 to the power k, 1 upon 2 to the power k. Now, as the loop, the condition in the loop is given I less than equal to n. So, what this condition means? This condition simply means that this loop will work till the time the value of I is less than equal to n. So, a loop will terminate when the value of I is greater than equal to n. Sorry, it won't come. The equal to won't come when it is greater than equal to. So, in that case, so again we will be writing here the value of I after k times is 1 upon 2 to the power k, and then this is less than equal to n. So if we do it here, like if I simply write it here, so 1 upon n is 2 to the power k. If we again do it here, the value of k comes log 2 is, so the time complexity for this, again it comes, the value of k again it comes to as log n base 2. Now, as I told in the previous type of example that how this 2 comes, this in that case, the value of I was being multiplied by the 2 every time the iteration was happening, and here it is being divided by 2 every time the iteration is happening. So the time complexity is big O log n base 2. Now, the last case that I will be covering in this video is about the nested for loop. For I is equal to 1, I less than equal to n, and I plus plus. This is loop. Now, if I will be nesting another loop which will run for the same time with a different variable like j, then it is simply again that loop will also be having its time complexity big O of n, and this loop, the outer loop, is also having its time complexity big O of n. So the resultant time complexity will simply become like what? It will become n into n square. So just to have a little bit of better concept, I will be taking here a loop with a different kind of syntax. Like it will be j is equal to 1, j less than equal to what? N, and j equal to j asterisk 2. Now this loop will be having some statements, isn't it? And this will bring us to the, like this is closed. So now the time complexity for the outer loop is big O of n, and the time complexity for the inner loop based upon the previous example where it is was multiplied, I told you it will be big O log 2. This will be n. So like if I just finally write it, so the resultant time complexity of the last code will be simply big O of n log n base 2. Now, just to give you a idea of the one last thing that I would like to tell you. Now, suppose in the inner loop, if it was from j equal to I, so you have to initialize, you have to check it for one instance, how long it will be run. So if I write here j is equal to I also, so like still it will be the very same loop. Again, if I will run from 2. So basically the value won't change. Only the concept here is related to updation. Even if you analyze the value of j. So initially, if I write it here, like I have written j is equal to 1 here. And if you take j is equal to I, when you are nesting two loops. So if you analyze the inner loop, it will again come to the place where you will find that the syntax is just the same if you initialize j is equal to 1 or j is equal to I. So when two loops are nested like this, what you have to do, I have just mentioned here. So this was basically the part that I wanted to cover here in the time complexity video one. So hopefully it must be clear to you what time complexity here is. And I will be taking about while and if in the next video. So do watch it. Thanks for watching. To share and subscribe. Thanks everyone.